Good evening, good morning, good afternoon to everyone. So we'll get started. And the structure of the webinar, here's a little bit of introduction about me, which you can read on the screen, is not very important. What is more important is the subject of the webinar. And in this webinar, I will talk about what is the need for an operating motto, right? What is an operating motto? What is the need for it? What are some good examples of operating mottos? So this is the first part of the webinar. We will spend maybe about 15 to 20 minutes on this topic. Then I will switch to projects and at least suggest that for most project organizations, almost every project organizations, and even knowledge work organizations which are not projects, focus and finish is a good generic motto that can be adopted. And we will spend about 20 to 30 minutes on this section. After that, once we have established a case for focus and finish, then I will also discuss what are some of the deficiencies in critical change project management in Agile today, and how we can enhance those solutions to for more focus and finish. Now, starting off, whenever we are managing organizations, it's clear that we need to empower people, right? People, when they show up for work, even on something as which is considered in the economic scale at the bottom of the pyramid, like a restaurant worker who is flipping burgers or who is a cashier at a restaurant, even they don't just perform the tasks that are assigned to them. They contribute also with their judgment and creativity. If the customer has a problem, then the frontline people have to exercise their judgment. If some problems come up in terms of maybe some workers are absent and it's peak time, what do you do? So you need to come up with creative solutions. And it is people on the front line who are going to do that, right? And of course, if you go up a little bit higher in terms of hierarchy, if we are talking about hierarchical organizations, then more and more, the higher you go, the less defined the tasks become, and the more and more you need to rely on people's judgment and creativity. But I think the main point here is that there is virtually no human organization which can function just in a command and control fashion. Even the army, even the military, soldiers on the front line need to exercise judgment and creativity. They need to follow orders, of course, but they also need to have judgment and creativity. Now, the challenge that comes up as a manager, as an executive, that I've seen personally, even in my organization, in realization, and we are a small company, we are about 100 some people, so it's still a fairly small organization. In a larger organization, which are our clients, I have seen this challenge even being bigger, that when you empower people, it can also hurt performance. And my reading on that is that the simple reason that happens is that local optimization, what you think is good locally, is not good globally. In fact, most of the times, local optimization hurts global optimum. So when anyone exercises their judgment and creativity and they approach it from what they see, which is their very local perspective, then the challenge will be that the solutions they come up with, they can hurt performance. I'll give you a very simple example. Uh, this was a long time ago when I first implemented drum buffer rope solution. So I was in Xerox and I was managing their materials management and production control function in one of the plants that used to make printed circuit boards assemblies. So you would take printed circuit boards and you put electronic components on top of it. And these assembled printed circuit boards, they go into copiers, printers, etc. that Xerox used to make. So we implemented DBR and we had great success. After I left Xerox to start Throughput, which was the first company that I started to provide DBR software to manufacturers, and I went back to the plant, in 3 months, the performance had gone back to where we started. So when we started, the cycle times were about a month long. We cut it down to about 6 days. We reduced the inventory by about work in process and finished goods and materials by about $75 million. And we increased the output of the plant by about 20 some percent. So when I went back, things had gone back to normal. And I investigated a little bit. So what happened? So this is what happened, that in the entire flow of doing these assemblies, there is a machine on the very front end. It is called a taping machine. And what this taping machine does is it takes electronic components and puts them into a tape. And then this tape is sent to the machines where the assembly is being done, and the parts get dispensed from that tape onto the printed circuit boards. So this taping machine, there were two of these machines running 2 shifts a day. So which means a total of 4 shifts a day. And they were operating at about 60% utilization. So a bright industrial engineer, he had a bright idea. Why don't we make some process improvement so that we can bring the utilization down from 60% to 50%, and then we can run these machines only on 1 shift instead of 2 shifts. So the person did a great job, being able to take a machine, improve its output by 20% so that the utilization goes down from 60% to 50%. That is actually a pretty good achievement. But the moment he did that, now the machine that had a lot of protective capacity suddenly ended up being the constraint for the entire operation. And that was the reason that the performance went down. Right? So this issue of local optimization is not good for global optima, is an issue that is there all around. In almost every situation that you can think of, there are very few situations where whatever is good locally is also good globally. And this is the challenge in empowering people. So this is a rhetorical quiz. So what is the best way to get alignment of local with global? Right? So should we give people detailed instructions like detailed schedules? And of course, once we do that, we know there will be exceptions and ideas. So then should we have an approval process where whenever someone needs to act out of the procedures or not inside the procedures or not inside the box, then those exceptions or new ideas, they need to be approved centrally. So for example, this industrial engineer, should we have put a constraint that an industrial engineer cannot make a process improvement unless it goes 3 or 4 levels up in the hierarchy, right? Should we train everyone in systems thinking, theory of constraints, etc., or should we just point them in the right direction, right? And the answer is, it is all of them. So when you're talking about something as complex as scheduling, right? Scheduling of multiple resources, multiple orders or multiple tasks, multiple SKUs in a supply chain, then it is humanly impossible for a person to calculate their own local schedule based on what is good for the global. So in that case, you do need to give people these detailed instructions or schedules. Right? So there are a few things which should be done centrally, and people should be given instructions coming out of that process. Exceptions and ideas, yeah, there is a case for some exceptions and ideas to be approved. Now, the challenge there is that you have to do it. You have to do it in a very judicious way. You cannot have an approval process before an idea gets implemented. Most of the time, what you want to do is you want to let people implement the ideas, And then you need to have a fail-safe mechanism whereby if an idea is hurting global performance, that issue gets highlighted, and then you can go back and make the reverse the change. So that is the only way to. So, for example, if you have a cost control process in the company, and now if you say that every $10, $20, $50 expense should be approved by someone before that expense can be incurred, the organization will come to a standstill. What you can do is you can say, you know what, go and uh, spend the money as you like. We will reimburse the money. But at the time of reimbursement of the money, we will look at, did you overspend in some area? And then we will figure out how to take corrective action so to prevent that in the future. Right? So that is a, a better way to correct the problem after the fact rather than having an approval process before the fact. Of course, if you're talking about large dollar purchases in this case, you want to do that central approval ahead of time. Training people in systems thinking, TOC, etc. I think it has merit. You know, if you want to train people in all of TOC, it takes a long time. But there are few breakthrough aspects of TOC, essential aspects of TOC, which are not taught in management schools, and this is to do all around with operations planning and scheduling. So the theory of constraints, the theory behind the TOC, which leads to the various operations management solutions, is not generally taught, and there is merit in teaching that theory to the rank and file, even to the rank and file. The last piece is just point people in the right direction and let people figure out what they need to do locally that is aligned with that direction. So I'll give you an example of this. An example is Copa Airlines. So this is a South American airline, and this was a case study that was presented by Stephen Covey at one of our conferences. It was way back in 2007, 2008 timeframe, I think. And the example he gave was, so this is how he started, and I think the whole process is important for you to understand. So he asked everyone to get up in the room, to get up, to close their eyes, and then face in the north direction. So wherever you thought the north was, you had to turn your face towards the north direction. And then when we opened our eyes, everyone was pointing in a different direction. So everyone thought that the north was in a different direction. And that was the point, that when people don't know what the North Star is, then they will go wayward. So the example that he used was the Copa Airlines example, which was a client of his. So this airline used to be the one of the least profitable and uh, worst airlines in terms of customer service. At least that is the case study that was told to us. And what they identified was that if we just manage to get every plane out on time, leave the gate on time, then costs will come down, customer satisfaction will improve. So that was the North Star that they gave the organization. They said, forget most procedures. You can violate every procedure that is on the books, except if it has got to do with maintenance safety and airline safety. Right? You can violate all other operating procedures as long as you get the plane out on time. And that was very empowering from people, from the way Stephen Covey told us, because now everyone would start collaborating. So flight attendants, pilots, everyone was doing whatever work was needed to get the passengers on the plane, to get them seated, and get the plane out on time. Right? And just by giving this North Star to the organization, what we were told was that Copa was able to turn around. This is a large mammoth organization within 6 months. Their on-time delivery went up to being almost close to 100%, and they became profitable. So that was an excellent example of an operating model, if you will. The other example I have is from manufacturing. right? So single piece flow is very popular in manufacturing, and whenever people, organizations are able to inculcate the single piece flow idea in manufacturing, generally those operations perform very well, right? And I'll give you know why this is so powerful. So there was a one of Bob Wallum. He's much before your time. You might not know him. So he was one of the earliest associates with Ellie Goldratt. And when I met him, he asked me a question. He said, "Do you know what is the dirtiest word in manufacturing?" So I was stumped, and he said, "Is setup." Because he said, no matter how well Dr. Goldratt proves that saving time on a non-constraint is a mirage, people will not set up a machine to just run 5 parts or 7 parts or 10 parts. It just does not make sense to people because it just is counter instinctive to say, I'm going to spend all this time to do the setups. And after I have done the setup anyway, there are going to be some issues. So the first 3 or 4 parts are not going to come out good. And then you are asking me to do a short run after spending 12 hours. Sometimes in the case of when you're manufacturing gears, the setup can take 12 hours, 18 hours. So these setups are really long. So after 12 or 18 hours of setup, doing a production run for 15 minutes just doesn't make sense. And the only solution to that is setup reduction, right? So you have to systematically take a process of setup reduction, and this is where single piece flow was so powerful, that we want to reduce the setup to the level where you can have one piece flow. You can just manufacture one piece and supply to the customer if required. Right? So this was the basic idea behind single piece flow when it came about from Toyota. They had things like single minute exchange of dies, etc., to enable the single piece flow. And now, if you think about it, when you reduce setups, so when people understand the single piece flow and you say, do what you can to enable the single piece flow, it is going to help everyone. When you reduce the batch size, we know the velocity goes up. When you reduce the batch size, inventory comes down. When you reduce the batch size and when the inventory comes down, the chances of misallocating materials and resources also come down. So this single piece flow is something that if people understand that this is what we are trying to achieve, this is our North Star, and then whatever action they take locally will end up helping the organization. And so even when you reduce setups, even on non-constraints, it is very good. So it's not that we're not talking about saving an hour in the when the operation is running. What we're saying is let's just reduce the setup for once and for all. So even when you reduce that setup on the non-constraint, it creates protective capacity on the non-constraint. And when you have this protective capacity on the non-constraint, you can shorten the lead time. You can shorten the rope length. So single piece flow is really that powerful in manufacturing. There was also another comment that Ellie made when I met him the first time in 1995, I think. This was in Phoenix. And we were sitting around a table for lunch. And somehow the discussion was about variability and variability reduction and Six Sigma. And what Ellie said was that setups are the biggest source of variability in manufacturing. Right? And what that means is that if we reduce setup size time, it reduces variability in manufacturing. Right? And it's obvious why setups are the biggest source of variability. If you have large setups, which means you have to run large batch sizes, the larger the batch size, the more variability you introduce in the flow, the more variability you introduce in the lead times based on how big a batch you are running. And if your setups are long, your quality is also erratic for the first few pieces. So that is also another source of variability. So when you reduce setups, you end up reducing variability also. Right? So this is how, in my mind, single piece flow kind of guides a lot of local efforts that if we make local efforts that are in line with single piece flow, it not only is good locally, but it is also good globally. Right. So if I illustrate local versus global, so this idea of single piece flow is not relevant for for projects, right? Projects by definition are single piece. So you do one project and that is what you do. Right. In manufacturing type of environments where you are making complicated machinery, yes, you can have a batch size issue on some of the machines when you are making some parts for multiple projects. But by and large, projects are single piece flows. Single piece flow is not helpful as an operating motto in projects. So let's see what is. So here is a hypothetical example where you have three projects. There's project number one, which has blue, red, and golden phases. Project number two, project number three. You can also think of this as not three projects, but three streams of work inside one project. Regardless, you have three blue resources, 9 red resources, and 6 gold resources. So if you put all these three resources on a blue phase, that blue phase can get done in 6 weeks. If you put all these 9 red resources on a red phase, that phase can get done in 10 weeks. And gold resources, if you put 6 of them, you can do it in 4 weeks. Right? And you have only 3, 9, and 6 of these resources. So which means in obviously the project will not take 20 weeks, it will take longer because you have enough resources to put only on one phase at a time. And these durations also include some interruptions that happen. They also include some idle time because not every resource will be busy. But when I'm a resource manager and I'm looking at this situation, I obviously see a problem that I don't have enough resources to support all the three streams. And if on top of that, I see people sitting idle during some of these 6 weeks, I don't think that is good. So I want to improve utilization. So I made a smart decision, which is I said, instead of taking 6 plus 6 plus 6 weeks, which is 18 weeks to get the three blue tasks done or blue phases done, I will split my three blue resources into 1, 1, 1 for each of these three projects or three streams. And I will be able to get it done not in 3 times the time, but only 2.5 times the time. So I have achieved higher utilization by spreading my resources thin. Ditto for the red resource, instead of taking 10 plus 10 plus 10, which is 30 weeks, if I take my nine resources and I put them, spread them as 3, 3, and 3 on the three projects, I can get all the three tasks done in 25 weeks. And same thing for the gold. If I take my 6 gold resources and spread them into 2 and 2 and 2, then instead of taking 4 times 3, which is 12 weeks, I can get it done in 10 weeks. And my utilization is high, and I'm able to get all the projects done in 50 weeks. So this is great. Right? But if we operate in a slightly different way, we say, you know what? High utilization, we are not going to worry about. So we will let resources sit idle, but let's operate in a slightly different way, which is the way I'm showing here. I'm going to take all my 3 people, put them on one project, and only after they are done with that one project will they be allowed to move to the next project. Similarly, all my red resources, 9 people, will be dedicated to this one project. And once they finish their work here, they can move to the next one. And same thing for the gold resources. Right? If I operate like this, now look at what I'm getting. I'm getting faster speed because the first project got done in 20 weeks instead of 50 weeks. Second project can start around here, which is the red task is the longest task. So after the red task finishes, you work backwards 6 weeks. So it starts here and it gets done in uh, another 10 weeks because the staggered is 10 weeks. So you're staggering these projects by 10 weeks each. And all the 3 projects as a result get done in 40 weeks. So let's just go through the calculation. 6 plus 10, 16, plus 10, 26, plus 10, 36, plus 4 is 40 weeks. So you got all the projects done in 40 weeks, which means in 50 weeks, you could have done one more project. Right? So this is counter to local optimization. Local optimization will say for a resource manager that I need to keep my resources fully utilized, so I'm going to spread my resources thin. Global optimization says that even if these during these 10 weeks, all these 9 people are not busy some of the time, that's okay. But we want to get this task done in 10 weeks. And the differences here is resources are spread thin versus focus and finish. And so this focus and finish, as I observe the more than 350 implementations of critical chain we have done, and even about 2,000 different construction projects that we have managed using critical chain, this focus and finish is always the idea that surfaces as the idea that yields results. So it's not aggregation of buffers. It is not reducing individual multitasking. It is this idea that as an organization, as a team, we are operating in a focus and finish mode. That is what brings about the benefits. And so if I take mode A and I buffer this plan, so what? So I can buffer the plan, but the point is I'm going to achieve 50 weeks. The reason the buffer is getting wasted is because resources are spread thin. So focusing and finishing your resources seems to be the central idea in projects. And if at every level, which is if you're doing a task, focus and finish the task. If the task is part of a larger phase of a project, like here, a blue phase, then focus and finish your resources on that phase to finish it fast. If you have a stream of work, then focus and finish your resources to finish each stream of work in a project as soon as possible. And if you have multiple projects, then focus and finish on a project to finish a project as fast as possible. Right? So we are not saying that you need to dedicate all resources to a project. All we are saying is you need to focus as many resources as are needed on a task, on a phase, on a work stream, on a project, so that you can achieve fast cycle times. Right? And why this makes sense, I'll give you a little bit of logic behind it. So when resources are spread thin, so every phase or every task ends up taking much longer, right? We say this. So in this particular case, instead of 6 weeks, it takes 15 weeks. Now, the longer a task takes, the longer the downstream waiting time, which means over in mode A, the red resources are waiting for 15 weeks before they can start their work. In mode B, the red resources are waiting only for 6 weeks before they can get started. And in projects, we know that the touch time to lead time is very high. So when we reduce the touch time, the overall lead time comes down very fast. In manufacturing, it is not the case, right? Where the touch time is maybe 5%, 10%, 20% of the total lead time. So over there, focus and finish will not have as much of an impact as in projects where the ratio of touch time to lead time is somewhere between 50% and 75%. So every time I'm able to execute a task or a phase or a work stream faster, the project gets done faster. The second side of this is the productivity of resources or the throughput from the resources. So what also happens is when resources are spread thin, work finishes in bow waves. Right? So what we mean by bow waves is that the red resources here in mode A are sitting idle for 15 weeks. And suddenly after 15 weeks, they get all the 3 projects in front of them. Versus in the second case, they start getting a steady stream of work after 6 weeks. They get one project, then they get the next project, and they get the next project. So the work is flowing in a much smoother fashion instead of bow waves. And when you have bow waves, it causes peaks and valleys. Peaks means your resources either are going to end up multitasking or your projects will end up taking even longer. And when there are valleys, that means resources are sitting idle. So you are losing on both sides. right? And the only challenge here is that these valleys are not easily visible in projects, because when we go in projects, people can always look busy, even if they are doing nothing. Let me also now give you some examples of spread thin versus focus and finish, right? So because this part is not obvious immediately, this is just what we have learned from all our implementations. So I'll give you some examples of spreading thin versus focus and finish. And so one example that we just talked about was this team sizing. So I've got a team of 8 people, 8 red people, 8 golden people, 8 blue people. I can put them on one project, which means the projects will get done in 5 days for the red task, 5 days for the golden task, 5 for the blue task. The project gets done in 15 and 10 days. But if I spread my resources thin, I take my 8 people and put 4 of them here and 4 of them here, then I get the task done faster, but overall cycle time has is now 18 days. If I do it in a focus and finish way, which is the way we talked about, then I can get my projects done in 10 days. And my throughput in this particular case, in the additional time, I could have done another 0.6 project. Right? So this is an example that we already saw. There are other examples, is one of synchronization. So, and we're not talking major integration points in a project. We're talking about day-to-day synchronization that needs to happen. You have some electrical work, you have some mechanical work that needs to be done in a certain area when you are building a ship, and the 2 people need to work in tandem. And if they are not synchronized in terms of what they are working on, the red resource, the mechanical guy is working on one area, the golden guy is working on a different area, then there's a difference between that spread thin versus focus and finish. So the meaning of spreading thin here is having different priorities for different sets of resources. The meaning of spreading thin in the first case is taking your people and spreading them across multiple projects, right? And again, you can do the calculation here, which is in terms of how much your cycle time improvement is, throughput improvement is. The next example is interactive work. So interactive work is also another one of those non-obvious examples, but it happens all the time. So when you are doing engineering, especially in the systems design phase of any product, any software, any complex system. So when you're doing systems design, the various disciplines, they are not working totally separately. So let's take the example of satellites. So when you are designing satellites, so you've got space engineers, you've got thermal engineers, you've got communication engineers. And there is a trade-off involved here in the sense that to manage the heat and the heat transfer, maybe you want to make the part smaller, a certain part smaller, but for communication you might need to make it bigger, right? So the point is that these 3 different disciplines, they need to work in tandem and share information between them or among them almost on a daily basis. Now if they are not focused on the same area together, you will end up with the same situation, that I am looking at my own task and the golden person is looking at their own task separately, and we exchange information when we can, which means we end up waiting for a specific task, for the task gets interrupted. Instead of taking 5 days, it takes 12 days, but I can work on 2 of these tasks in parallel. Versus if I said these red and yellow tasks, golden tasks, are not 2 separate tasks, this is all just one task. And this task needs 1 red person and 1 golden person. Right? So then I achieve more of a focus and finish. And again, you can see the impact on cycle times and throughput. The final example of focus and finish versus spread thin, which is endemic to all projects, is the management capacity. Right? So our project plans say that projects flow from left to right. In reality, projects do not flow from left to right. As you are executing a task, problems come up. Decisions need to be made. Those decisions and problems flow up to your experts, or to your managers who can make all these decisions. And once they have made a decision or solved a problem, then the execution of the task can begin again. Now, there's a lot of variability in this response time. So whether solving a problem, it can take 5 days, it can get done in 5 minutes. Because of this variability, what you have is a situation where your the basic queuing theory, which is as your queue size, number of tasks goes up, the time it takes goes up exponentially. Right? So this is almost a freeway effect where there are certain number of cars, the freeway is flowing smoothly, but as soon as you hit this inflection point, suddenly the traffic comes to a standstill. Right? So this is the same thing that happens with management capacity. That if managers get overloaded, if they are not able to focus and finish on one thing at a time, then when managers get spread thin across multiple tasks, then everything comes to a standstill. So a better way of executing this is instead of having all these 4 projects going on, you have only 2 projects at a time going on. Right? And this is actually one of the main ideas that we use in staggering of projects also, which is we don't look at just resource capacity, we also look at management capacity to decide how many projects can be done at a time. If we accept this idea of focus and finish, there are 3 implications I just want to point out very quickly for the planning side of the solution.
Sorry, Sanjeev, there was the clarification question. What is the task IP?
Very good, thank you. Tasks, number of tasks in progress for any given department. So what you have here is for the red department, for the red manager, now they have to manage only one task here, and versus over here they have to manage 2 tasks at a time.
Okay,
Right? So the
and
number of tasks in progress is also coming down, which leads to more management focus.
Well, can you go back to slides? If we already just on the content, there was, yes, this one. Well, there was something that you said about this middle line where the blue resources take 15 weeks, red 25, and golden 10. And just, can you clarify what you mean? Because I think this might be a question just for some people. You said that the red resources have to stay idle and wait for 15 weeks until they can start working on the project. And I think that this may raise a question, why the resources would be standing idle. What do you mean standing idle? Let's say if they're subcontractors, they will not stand idle, they will be busy just with somebody else. If they're internal resources, they will certainly be working on something else. This is probably unthinkable of having resources 15 weeks being idle in an organization. Can you clarify that, please?
Sure, absolutely.
Thanks.
So definitely resources are idle from the perspective of this project, right? They're not working on this project, right? So there is time on the critical path of the project that is getting lost, right? So that part is clear. And now the question you are asking is, if I'm faced with this situation, I will put the red resources somewhere else, right? So when I do that, then I'm spreading the resources even more thin. The assumption that I can take these resources and put them somewhere else because the organization does not tolerate idleness is actually not correct, because the organization does not have infinite amount of work that it can perform. There is a limit to how many projects there are going on in the organization. So what happens is that people start doing things that make them look busy, but they are really not busy. Or people start doing things which might have to be reworked, which means they are busy, but that busyness is actually bad because it is going to get reworked anyway. So let's look at some of the implications for planning. Right, so for project plans, whether you are doing critical path, critical chain, doesn't matter. Right? The problem with project plans is that you can decide how much detail you want in your project plan. Right? Some people can create very detailed plans, some people can create not very detailed plans. But the critical path or critical chain always runs at the lowest level that you have defined. So that is what happens in all project plans. That when you determine the critical chain, whatever is the lowest level of detail you have defined, that is where the critical path and critical chain is running. Now, to encourage people not to have very detailed plans, we come up with things like, a project should not have more than 150 tasks or 200 tasks. Right? But that does not make sense. Sometimes the project plan, if it's a very small activity, you can have a project plan of 3 tasks. And sometimes that is a large activity like constructing a thermal coal power plant, design and construction of it. That can be thousands of tasks. Right? So imposing a limit on the number of tasks is very artificial and arbitrary. Right? A better guiding mechanism is, what is that amount of work? This is my work. What is that group of work that needs to be all done together? And that is a task for me. Right? So for example, if I'm doing design, and that design consists of doing 25 drawings. So all those 25 drawings are subtasks which can get assigned to different engineers, but I better do all those 25 drawings related to, for example, a turbine blade, when I'm doing a turbine design, together, instead of spreading my resources thin between designing a turbine blade and the rotor and something else. Right? So this two-tier tasks is a very important concept, which means the actual work is happening at the subtask level or the tier 2 level, but the critical path or the critical chain of the project is running at the tier 1 level. Now, what this does is that because the critical chain is running at this level, these subtasks, they always stay together. Right? So my task can move in or move out based on the buffer consumption, but all the subtasks below the higher level tasks, they always stay together. Right? So they are, when I start this task, I'm going to get all these subtasks done together. Versus if my critical path or critical chain was running at the subtask level, buffer management and other exigencies, they will cause my subtasks to get spread out all over the place, and they will not be executed in a focus and finish manner. But let's move on to the next part, which is multi-project planning. So in multi-project planning, what we have found is, when you are doing the project stagger, it should be based on phases, not individual tasks. Right? So there was in between an evolution where Ellie came up with the idea that you should do staggering based on systems and integration and testing phase. That is not true. Right? That was just an idea that was not fully evolved. The main idea is that instead of staggering projects on tasks, we should do it on phases, because we want the entire phase to stay together and be executed in a focus and finish phase. This phase can be my systems integration and testing phase. The phase can be design phase, or the phase can be development phase, wherever I have resource constraints or the most loaded resources. Right? So, but the main idea is that the staggering of projects should be on phases, not individual tasks. What I can tell you is that the way we do the implementations is that we identify different phases of a project, and we identify which phase has the most severe resource constraints, and we use that phase to stagger projects. The third aspect I want to point out is in terms of sprints. So because we follow not critical chain, but we follow the agile process when we are developing our software. And the issue that I found was that sprints are great because now you can focus people on a smaller set of features versus having a waterfall plan with many features, and the project is going to take 6 months, 7 months, 8 months to finish, versus getting a set of features finished in a short sprint of 4 to 6 weeks, then move to the next one and moving to the next one. So sprints are great, but the problem with sprints is time boxing, which is having a policy saying we will have a release every 4 weeks, or our sprints are always going to be 3 weeks long. That doesn't make sense, because what that was doing even in our own development process is, because there is time boxing, you end up either not completing a feature, so you do only a little bit of work in the feature set, but don't really make it a very complete feature, or you end up doing some half work that doesn't go into the product. And because the next sprint has already been planned, all the unfinished work from the previous sprint, it will start showing up as backlog. So sprint teams maintain, there are software features in sprint agile software which allow you to maintain a backlog from the previous sprints. And more importantly, quality issues come up. So you release your product with a feature set that is not complete or not fully done. Then you experience problems when people start using the software, and that flows up as a quality issue. A better way is to say, define what is the scope we want to do, and say, we are going to finish the sprint, consider the sprint done when this scope is done and fully tested. It doesn't matter whether if it takes 3 weeks, 4 weeks, 5 weeks, or 2 weeks. From a planning perspective, yeah, on an average, it will take 3 weeks, but it can get done in 2 weeks, it can get done in 4 weeks. Let it get done when it gets done. But we are not going to artificially release a version of the software every 3 weeks. Okay. So just a few observations based on what I have presented so far, right? And I have pointed these things out. But in my mind, this whole debate about buffer aggregation, buffer sizing, 50-90, how do I do the estimates? Where should I draw the curve, the slope of the curve? What should be green, yellow, red? And that is just unnecessary discussions, unnecessary thoughts in critical change. Right? It doesn't matter whether you're defining the slope of the red zone to be more than the green zone, less than the green zone. All that doesn't matter. What matters is focus and finish. All the benefits come from focus and finish. They do not come from the fact that we took the safeties out of individual tasks, and therefore we reduce student syndrome, and therefore we reduce Parkinson's law. And now the buffer that we need at an aggregate level is less than the buffer that we need at the, who knows about all those things? Who knows how much buffer do you need? This is a project. No one has any statistical data about these buffers. The next point I just made, which is converting waterfall projects into sprints wherever you can, it encourages focus and finish. But if you do time boxing, that is bad. The next point is also important in my mind, and this is related to the question that Nereus was raising, which is what is spreading thin. Right, so focus and finish is not about stopping one person from multitasking. That is not the point, because multitasking at a task level is bad locally as well as globally, right? And people multitask because they are forced to multitask. That is not the point. The focus and finish is more about, as an organization, being able to concentrate the right number of resources on a specific task or a specific phase or a specific work stream or a specific project. That is what focus and finish is about. Final point is subtle point, but for those of you who have done critical chain implementations, you might have found that buffer management can sometimes cause you to multitask. Right? So what might happen is, with buffer management, as you find some red tasks, you move your resources to the red task. But when you move your resources to those red tasks, then something else becomes red. So you move your resources to the other tasks. Right? And so now imagine if you're running buffer management at the subtask level. So, sometimes you are performing subtasks under task number 2. Sometimes you are performing subtasks under task number 3. Sometimes you are performing subtasks under task number 4, depending on what buffer management is telling you. So this will now start causing your resources to spread thin. Right? So that is why it is important to structure the tasks for focus and finish. So at this point, I will open it up for questions.
Sanjeev, from the timeline, how can one understand that this task would be critical from the timeline perspective? So if there are no buffers, just for now, the signal is received through the buffer management.
Well,
And well,
I can always calculate the critical path of a project. I can always calculate which path is most critical, second most critical, third most critical, right? So as long as I'm doing that calculation in real time, I don't need buffers to calculate task priorities. More important is being able to calculate the critical path on the fly in real time as completions are getting reported.
So just what do you mean the longest chain, actually, the remaining longest chain?
Exactly. Remaining longest chain is the most critical.
All right. So,
right? Okay. And that is how we do even buffer management. When we have buffers, we are finding out what is the remaining longest chain.
That's correct. Absolutely. Yes. Okay. So what then will be the mechanism to do this calculation? Right now, this calculation of the remaining longest chain is done through the mechanism of buffers. Yeah. If buffers,
there are different algorithms, right? So some of our clients, they don't want to use buffers, so we have built in a calculator which does a calculation of critical path versus how much total time is there between today and the project completion date. So we can calculate it from there. So there are multiple ways to do it. It's not optimal. Buffers, I will tell you what is the importance of buffers. Right? I will come to that in a minute. But priority calculation can be done without buffers. Right? Yes. So if I look at this picture,
yes,
and let's say that this 3 tasks is my critical path, and there's another chain which is not the critical path.
Mm-hmm.
Now, if in this project plan I leave the task as it is, then what is happening is the non-critical path does not have any slack in front of it.
Mm-hmm.
But imagine, so to do a calculation in real time, so imagine each of these tasks, just to make it up, is 15 days long. So 15, 15, 15. So total project duration is 45 days. So I have 2 options. I can leave the project at 15 plus 15 plus 15, total of 45 days. Or I can reduce the task to 10 plus 10 plus 10 and add a 15-day buffer at the end.
Mm-hmm.
When I add a 15-day buffer at the end, what it does is there's 15 days at the end. Then the last task is 10 days. So 25 days. So this task here, on the non-critical path, it is planned to finish 25 days before the end of the project. The moment I put a project buffer in, what it does is it starts creating a slack on the non-critical path. Because now I'm trying to finish so if I don't put the buffer, then this task here, not on the critical path, will be planned to finish 15 days before the project end. But if I put a buffer, then this non-critical task will be planned to finish 25 days before the project end. So I'm getting an extra 10 days of slack on the non-critical path. So what now will happen is that as you run your priority system, if you don't have the buffer, then the priorities will shift frequently. If you have the buffer, then the priority will not shift that frequently. And that is the power of buffers. Buffers, why they are needed, is for focus and finish, not for aggregation of uncertainties and buffers. They are not needed for priorities. They are needed for focus and finish. Because the moment I put buffers in, it keeps the priorities more stable. And when priorities are more stable, it allows me to finish what I'm working on before being pulled into something else.
Yeah, so there was the question, can you elaborate further on why to stagger on phases? It was not clear what you meant. It was the...
Okay. So let's go back to this picture here. So imagine that this red phase is actually comprised of 20 different tasks. Okay. Now, when I try to stagger on tasks, what might happen is that as a resource becomes available, I might pull in some tasks from the second project to the left, right? So when you are scheduling at the task level, then you are increasing the chances that you will pick up tasks from multiple projects or in the same time frame, right? If we agree that the best way to execute this project is to do this phase first and then this phase and then this phase, and if we agree that if we try to improve the utilization of resources in this manner, that is counterproductive, that is kind of the answer. So if I'm putting a scheduling software in and it is scheduling task by task, in an extreme case, it might end up scheduling my projects in a way where my resources are always busy and the total amount of phase time, cycle time for the phase ends up being 25 weeks. Right? Because scheduling software is just going to do what you would do as a normal human being if you schedule task by task. But if you say that no, based on the understanding that my red resources are the constraint and they get mostly used in this phase number 2, which we are calling the red phase. So let me do the stagger on phases.
And why not staggering on the resource? There was additional question from the Egmont.
Very good. No, I am staggering on the resource, right? So phase is not, I have not picked this phase in this case. So this example is bad. So I did not pick this phase because it is the longest phase. I picked this phase because my red resources are in the shortest supply. So for example, if I had this red phase is my longest phase, but let's say that instead of 9 resources, I had 18 red resources, right? So my constraint in that case would be the golden resource. So then I will stagger based on the golden phase. So it is, the idea is to not overload the resources, which means we have to look at the resource constraint. But then what we have to look at is, as a function of that resource constraint, which phase are those constrained resources being used, and let's stagger based on those at a phase level rather than at the task level. Right. So to make the point again, if I had twice the red resources, even though red phase is the longest phase, I will do 2 red phases in parallel, but I will not be able to do 2 blue phases in parallel. So I will move this project to the left by another 4 weeks, not by another 10 weeks.
So basically, if I got it, you're right. So you are just, the difference is that we are staggering through the resource, but not on the task level, but on the phase level.
That is correct. Thank you. That is a much better way of saying it.
Okay, thank you. How often are tier 1 tasks updated? Is it?
Very good question. So tier 1 tasks with this planning structure, what we find is, first of all, you don't report remaining duration on subtask. You report when you are done. When you finish a subtask, you say you are done. You don't need to do remaining duration update at this subtask level, right? And as the subtasks get completed, the software can automatically kind of assume some remaining duration update. And then depending on the project, sometimes we have projects where at the task level, you are doing remaining duration update maybe twice a week. So twice a week is very acceptable in a lot of engineering white collar organizations. When I go into construction projects, the remaining duration update, and no one has time to think about what is the remaining duration every day. So in a large construction project, a weekly update of remaining duration is good enough. But that does not mean that the status is not being updated daily. The status is being updated in real time. As you complete a subtask, it gets reported and it gets reflected in the priorities. But the remaining duration update at the task level does not need to be real time or even daily. Twice a week is good enough, even once a week is good enough. I'm aware that I'm challenging a lot of orthodoxy from critical chain, right? But I'm talking from a very practical perspective here.
There was the question, what to do when assigning people for 100% to one task doesn't speed up completion, like supervision work or task that takes 2 months but only requires
Very good.
100-hour works. Is it possible to level despite part-time assignments?
Now, that is the case where there's this case. To me, those resources are kind of this management and support resources. They are not needed for the entire duration of the task, but when they are needed, they are needed. Right? So the objective here is not to level load them, but to operate such resources at somewhere less than 60-70% utilization. Because, so let's say that you have a 4-week task, and out of that 4 weeks, you need some supervision resources or some inspectors only for 3 days. So let's take this extreme example. Now, can I predict exactly when I will need them? The answer is no. It depends on what is happening with the rest of the task. So I don't know when they will be needed. But when they are needed, they need to be instantaneously available. And there is this concept of instantaneous and non-instantaneous availability of resources that is, a lot of people from drum buffer rope are familiar with. But the point is that these resources need to be instantaneously available. If they are not, the task will stop. Now, to assure this instantaneous availability, you need to have a lot of protective capacity there. So you cannot level load these resources at 100% of their capacity.
Okay. If I understood Eli right, he said that staggering based on resources will show too much variability. Because of that, he called for staggering phases. Is there a contradicting with your argumentation?
I think Ellie's intuition was awesome, but his logic in this particular case was not fully developed. Right? So his idea that it should be based on something that is not a task, was great intuition. But the logic of what I'm pointing out, I believe that logic is better.
Sanjeev, I would like really to thank you very much for this outstanding webinar. It was really enjoyable and remarkable. Just wanted to point out to everybody that Sanjeev is one of the really significant leaders in the logistical areas of TOC. And we are really, really happy, Sanjeev, that you join us and share your experience and your views.
Thank you for this opportunity.
Okay, thank you everyone.